Hello, hello. I'll start in 6 minutes. Welcome, welcome.
objects fall in power network. I would like to take a short look on rectifiers. Nowadays there are many objects what are powered through the DC stage. So effects of phenomenon of rectifier is worth to be studied. First, let's see classical version from old good days. What we have? Transformer powered from AC. I don't know, 130 volts AC. Secondary winding. Rectifier bridge, capacitor and some load. It's a classical. Maybe it's ground, but not important. I have assembled such network. Here, I have transformer, I have rectifier, this is my load, load's voltage, and set of capacitors to demonstrate effects on filters. I have two signals to my scope. My first signal is a current of supplying AC line. My second signal is a load voltage. Okay, now zero capacitance of filter. Classical form from your book. Sine as current on primary side, bit disturbed, I can, here I unplugged load one. We see some third harmonic, it's a magnetizing current of my transformer. Connect them, here, nice sine current at input, okay. And classical two waves at output of rectifier. Now let's add filter capacitor. This one is without any filter. Load voltage isn't DC. We would like to have DC, but it's not DC. Let's add capacitance. 20, 40, 80. See what happens. Current started. We see disturbance. Right. This block. 200 microfarads. Voltage is closer to DC. But what happens with current? What's going on? Very simple analyze. Let's say I have source going up. Then it goes down. This is enough for me. This line is a charge of capacitor voltage. Current here is my capacitor ground. before net voltage is above capacitor charge, no current flows because the load is closed. 0. Then, started from this point and up to this point, current will be something like sine pulse. And again, 0. Short pulses charging my capacitor. More should be added. Here, I left space. In this space, I need to add transformer's active resistance and key transformer's inductance. On the current load, I have transformer's inductance. Okay, to go forward, 33,000 microfarads. Oh, large condenser. See, now filter is sufficient to make nice DC. But what happened with primary current? Sharp waves. Spectrum analysis. Spectrum analysis of current. What do we see? Oh, 50 Hertz, base frequency, 150, third harmonics, 250, fifth harmonic. I would also like to draw attention to the load voltage. Small filter, good, large filter. You see how? On DC side, now it's fine. On AC side, the higher capacitance of filter, the shorter is period of current flow. Look, tiny filter, 80. No filter at all. Nice. But this thing what I've shown now, it's an old style where we have 50 Hertz transformer. It's an obsolete. Now we live in different world. Now we live in world when small input filter, rectifier free, here 230 volts AC supplying line. Capacitor, from PWM controller. Here is modern schematic. Transformer operates at high frequencies, 100, 500 and more kilo hertz. And DC side, rectifier is on a high voltage side. What this changed? 1 second, I will assemble something. This will be my wall. This experiment. And come here. Volt meter disconnect. And something goes wrong. Why it goes wrong? Oh, sorry. I forgot one tiny thing. Oh. No, it's not liquid. Here. Need to switch. Power from directly from network without transformer. 20 microfarad, 30, 8, I don't have sufficient capacity. Is low voltage, is current. Under filter, what happens? Filter capacitor discharges during what happens? First diode opens, capacitor charges, then it's discharged, and we see second open of diode, second pulse of current. Third harmonic, approximately 3/4 of the base. Very serious disturbance of call it. See, it was flow on the network. I can increase silence. Better filter. You see what voltage increased? It's better, and we see only one current pulse. This way better, but again, do you see what's going on? Base frequency 50 Hz, 150, they are nearly equal. Huge amount of third harmony flows through network, and in network neutral, in polyphase network, where we have single phase loads, but all around, we will see triple this part flowing through our network. Why it's harsh? Because I don't have inductance of transformer before my rectifier. That's why the current pulse are so. Okay, but this is here we see case of single phase load, more than single phase load. about polyphase law? What about three-phase? It's more complex. I need what I need.
Okay. 1 minute, I will assemble test network.
What will be my test network? A big transformer. Ground. Full bridge rectifier. Here will be ground. Again, I will take here with the help of load current transformer. This will be my signal number 1, and lower voltage will be my signal number 2. Transformer. 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 Here is transformer. My three-phase transformer. I will. What is this? This is phase A goes here, goes here. Phase C goes here. Phase B goes here, and this will be my negative. Okay, connected. Here it is. Yellow line, current of A phase. Blue line, Watts voltage, and now I have zero filter, no capacitors at all. Pure rectifier. See? 6 waves for one period of primer. It's a 3-phase rectifier. So for each period of supplying voltage, I have 1, 2, 3, 4, 5, 6, 6 waves on secondary side. Here, spectrum of A-phase current. What do we see? 50 Hz? Yeah? And something missing. What should be here? Here. 50 Hz here, 150. Where is third harmonic? No third harmonic. This, because secondary side is connected, there is no ground wire. There is no way third harmonic can close, can circulate. In case of polyphase, full bridge rectifier, there is no third harmonic and primary current. I can switch yellow line is a neutral current. Here we see small presence of third harmonic. Why? Because it's a magnetizing current of transformer itself. Now here, phase current. I can add what? I need filter. I need better quality of voltage. 20, 40, 80. Not enough. 200. See then? Double open of diodes. Spectrum of current. Base frequency 250 and 7. Not much better picture than on single phase rectifiers. Okay, where is my plug? 200. Sufficient filter. It's 33 millifarads. I have nice DC on load side, and what on primary side? Double waves. That's what we see when full bridge is supplied. Star-star transformer. These double waves, because they have two opens of diodes. With smaller filter, this is insufficient. We see increase in 7 and 11. Good quality filter. Here. Here's the picture. What? Okay. This is star connection. What if I move to delta connection? One moment, I will reassemble to delta. It takes a small time. there should be a nice star delta switch. But I code mistake, but I assembled without it. Now I have delta connection. Voltage. Delta without the filter. See improvement. Small filter, good filter. Here what we will see on primary side when transformer is with delta connection. Close to side. Delta connection improves quality, let's say, reduce impact on network. I can, for illustration, this was all type of rectifiers, selenium type of rectifiers. In all the kind of used in Harmonics. Here it's all type of rectifier. See? Less harmonics, but there is problem. This type of rectifier has high internal resistance and less efficiency. The best rectifiers mean sharp current switch. Sharp current switch means higher level of disturbances for network. But economy is a driver here. Nice DC, but this is what you will get on primary side. In case of full bridge rectifiers, primary side current will contain base frequency, fifth harmonic 7, but no zero sequence, no third harmonic. Questions?
In that rectifier we have 4 diodes inside.
Here 6.
6.
6. It's full bridge. 6, 6. For single phase, 4 diodes, typical. In case of full bridge for polyphase, 1, 2, 3, 4, 5, 6. Yeah, 6. Here, 6. 1, 2, 3, 4, 5, 6 plates. Polyphase full bridge. Single phase, simpler. Where will we see single phase? PC, lighting, I don't know, audio visual equipment. There will be single phase. Where will we see three phase? Frequency inverters or industrial load, things like this. And they are very different if you look on them from I would say with signal theory lens. In case of single phase loads, even combined in three phase, we see huge amount of third harmonic. In case of larger industrial, there is no way third harmonic can close, so they do not produce third harmonic, they produce fifth. And fifth harmonic do not fall in a neutral. There is no fifth harmonic in neutral. Okay, maybe some questions. I see people on the line. Something you would like to know? Science, they disappeared. Okay. Cool. Polyphase. High level profession with huge experience. They make mistakes on this moment. What harmonics flow in neutral and phase? And what's their influence? One of the things when you have huge penetration of of single phase loads, you saw amount of disturbance they cause. Cosine improvement capacitors. Huh? Power factor should be improved. Power factor improvement capacitors, but they cannot extend. Such high current. Sometimes even below. Yesterday I burned my rectifier. Oh, what?
He said you would have got. Then I asked him what was it, he said he's not going to just do it. And it's similar to because the fault is kind of easier than the fact.
Seriously?
His formula is just you calculate. But he didn't submit it. So that's why. And I don't know if he said
I don't see any question.